So continuing, here is a summary of all that we saw. Order, list, tuple, array. They represent ordered sequence of elements. They use the concept of index for designing the location of an element within the sequence. Mutability, okay, changeability. Distinction between a list and tuple is that list is mutable, tuple is immutable. So mutable means you are able to insert, replace, remove, append, extend, and so on. Okay. Associativity. Python's dictionary class, dict class, is used to represent an association between a key and its value. Heterogeneity. A collection is called heterogeneous if it can hold elements of different types. Okay? If a collection can hold only one type of elements, then that collection is called homogeneous. So only homogeneous case we saw was array. All right. Heterogeneous. So I hope this is clear. Order means you have an index 0, 1, 2, 3 until n minus 1, right? That is order. Order matters. Mutable. Mutable means you can change. Associativity. This you see only in the dictionary class. You have a key and the value. Heterogeneity means, for example, your list or your dictionary, they are all heterogeneous. Tuple, that is heterogeneous. Set is heterogeneous. Means what? You can put various types in it. You can put string, you can put numeric types, you can put list within a list, and so on. Okay. Now, which brings me to storage. Most of Python's containers are referential. That is, the value of the elements are not stored internal to the container, but indirectly as references to other objects. I hope this is clear. See, the list, be it a list or a tuple, or it doesn't. So suppose I make a list, right? Suppose I make a list 3 equals 3, 4, 5, 7. Okay. This number 3, this number 4, this number 5, this number 7 is not sitting inside. But there is a position kept in place. That position is what we call index. So that position 0 refers to 3. 3 is not sitting inside. That position, that place refers to it. Okay. In other words, we are not wasting space and time by putting things in here. We are just keeping those positions in mind, which will refer to whatever you're assigning it to. Okay. So that is what makes it very efficient. Okay. Python uh, that's another reason why heterogeneity is supported, because it's the position which refers to a string. The next position may refer to a list itself, next position to a numeric quantity, so on. It's just the position sitting there. It's not the various objects are sitting here. All right. So heterogeneity is supported. But the indirect nature of the storage can be less efficient in terms of memory usage and access time. Not memory usage as much as access time. For high performance applications, Python supports an array class, which provides compact storage for a collection of data. Okay. So here is a small summary of various things, the properties that a list has, a tuple has, dictionary has, and so on. Okay. Now here are two familiar containers, list and tuple. List and tuple are used to manage ordered sequence of elements. Position of a particular element within the sequence is designated with an index. We may view both the list and tuple as an association between indices and values. Notices indices must be consequent integers, 0 to 1 less than the length. So now notice, I cannot go from 0 to 2 in index. I go from 0, then 1, and then 2, and so on. What are the limitations of the use of a list or tuple? First is lack of permanency. Items in a list are identified using indices. But if one element is removed, then indices of all the elements which come after change. For instance, suppose you have an employee list. Employee indexed 15 has retired. Then whoever was 16 previously now has become 15. 17 previously became 16, and so on. In other words, index is not permanent. If I remove this item, the next person will get a previous index. So a person's index is not permanent. Another problem is of large numbers. Suppose we want to identify employees by their social security numbers, or identify books using their 13-digit ISBN numbers. Placing these elements in a long enough list is a waste of time. So suppose your social security number is 111532 whatever. Are you going to make a list of such a large list that all the earlier numbers are empty, comma, 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 until it comes to the very first social security? That's a waste. So it's better not to use a list for something like that. Another issue with list is non-numerical identification. Sometimes elements do not have numbering scope. For example, movies. There is no such, your movies are not numbered 1, 2, 3, 4. All right, there are certain other numbers, like for a book. Books are numbered via ISBN. Okay, so better than a list is a dictionary class. What is dictionary? So summary, dictionary is an associative container. It represents a mapping from objects known as keys to objects known as values. All right, keys are identifier. Keys have to be unique. So for one social security number, you should not have two different people. One social security number should get you only one person's name. All right. Thus, employers rely on social security numbers. Okay. Or books are numbered using their ISBNs. Keys could themselves be tuples. Okay. Keys can be tuples, keys can be numbers, keys can be strings. That's okay. All right. Keys must be drawn from an immutable class. That's an important issue. A key should not be mutable. So you are not allowed a list for a key. You are allowed an integer, a string, or a tuple. All right. If a key were allowed to change, the original placement of the element may no longer match, and that's useless. Okay. So keys must be immutable. Okay. Now, all keys within a given dictionary must be unique and immutable. Values, on the other hand, there are no restrictions. They can be from any class. They are not required to be unique. So here is a dictionary, flowers. This constructs an empty dictionary. So is this, right? This is just the literal form. Red, rose. Yellow, daffodil. White, lily. That gives you a dictionary. Now this dictionary will get filled with key value, key value, key value. Here is another dictionary. A to U, C to G, G to C, and T to A. All right. Here are some supported behaviors. Now this, mind you, unless you try it yourselves, you will not understand what's happening. So first, create a dictionary, any dictionary, and play with this throughout. Okay, create any dictionary and play with this. Until then, bye.